Hello everyone, my name is Dương, and today I will present to you my lesson plan about how to teach the law of energy conservation. So first of all, I want you guys to know what kind of student that I want to teach. They are at the normal level, like they are familiar to some apparatuses that they have just done in the previous lesson. And they also can deduce some consequences that can be checked by doing experiment. And I choose the way is to verify the law of energy conservation. So I expected the student can design the setup of the experiment and can observe, manipulate, and execute the experiment. And also discuss about some limitations of the experiment. And to engage the student to verify the law, I will mention a situation. That is, when the ball rolls down a curved, rough surface, they can see that the ball cannot reach the initial position. But we have just learned from theoretical way that the total mechanical energy must be conserved. That means the potential energies must be converted entirely into kinetic energy and vice versa. So the ball must reach the initial point. But it doesn't happen. So is the law wrong, or are there any conditions that must be met if you want to make it happen? So I will ask students to design an experiment to verify the law of energy conservation. And I will ask them to tell the context of the energy conservation, that is E equal to constant. So the initial total kinetic and potential energy must be equal to the total kinetic and potential energy at the last position. Like this, mgh0 plus mv0 squared over 2 is equal to mg8 plus mv squared divided by 2. And I will ask them what is the easiest way to choose the initial position. And they can see that the easiest way is to choose the initial velocity is equal to 0. And then they can think of the experiment that they did in the previous lesson about the free fall acceleration. They will use a linear track and a digital timer, a magnet, photo gate, and the support like this, and connect the photo gate to the digital timer and also the magnet. And then from the experiment in the lesson of free fall acceleration, they measure the time interval in delta t, and then they can use the characteristic of free fall motion is a uniformly linear motion, and then they can calculate the velocity when an object comes to here, and then use the ruler to measure the age and plug into this equation to see whether the law is right or wrong. But that's not my intention. I will ask the student to tell what is the limitation of this SketchUp and the procedure. And then they can see that it is too complicated because they need to measure the time t and also need to do some calculation. So I will remind them about the way how to verify something. We have two ways. The first one is we can verify directly from the conclusion. And the second way is we can deduce a consequence and then check the consequence by doing experiment, so that they can think about the second way. And then they can choose h0, h, and then they can measure v. And they can calculate v from this equation. And by assumption that the instantaneous velocity here is equal to the average velocity that an object blocks the photo gate. And then they can calculate the time t. when the object blocks the photo gate. And for example, I choose that H0 equal to 50 centimeter and H equal to 0 centimeter, for example, like this. And then I will calculate V, and V is equal to S over T. So what is S? S is the length of an object. I will use this ruler to measure the length of the object. And then I can calculate that T equal to 0.006 second. And that's I need to measure from the experiment. And I will come up with the final design of the experiment. We should note that we shouldn't deny all their efforts to set up an experiment. We just show them a better way based on their idea. And then the procedure is I will let an object fall freely from here to here, and then measure the time on the digital timer. Is it equal to 0.006 seconds or not? If it is, the law of conservation is verified. And by doing this experiment, we not only check the law of conservation, but also show them that the condition that the law can be applied. Because think again about the situation that I have just mentioned at the beginning. The ball cannot reach the initial position because of friction. Then you know that friction force is a non-conservative force. So some amount of mechanical energy is converted into heat, so that the potential energy here is not equal to potential energy here. And now I will do the experiment. I have some notation for you that by doing this experiment, we should make sure that the track is vertically. We can check it by using the plumb here. And the photo gate is connected to the gate B. So I will use the mode B here, and the scale is 9.9 seconds. This is our object, and you can use the ruler to measure that its length is equal to 2 centimeters. Turn on the digital timer and attach it here. Push the button. You can see that the result is 0.006 seconds. So the law of conservation is verified. That's all. Thank you so much.